Welcome. We're going to do first come, first serve for spring 2017. So this is first come, first serve. And let's get started. So these are your processes. You have 9 processes, P1 through P9. And all processes have arrived at time 0. And since it's first come, first serve, they're going to go in the order in which they arrive. So the current time we start is time 0. We have P1. P1 has a CPU burst of 24 time units. So P1 will get on the CPU for 24 time units, and then we'll go out to I/O for 31 time units, and we'll come back into the ready queue at time 55. Next, we have P2. P2 has a CPU burst of 15 time units, so it will be on the CPU until time 39, at which time it will go out to I/O, and it will be in I/O until time 74. Next we have P3. P3 gets on the CPU. P3 has a 17 time unit of CPU burst, so it will be on the CPU until time 56. And then P3 will go out to I/O for 21 time units, and will come back into the ready queue at time 77. Now we have P4. P4 gets the CPU for 15 time units. This is first come, first serve, non-preemptive. So P4 will be on the CPU until time 71. At time 71, P4 will go out to I/O for 35 time units, and will come back into the ready queue at time 106. Next we have P5. P5 gets on the CPU from time 71 until time 77, because P5 had a CPU burst of 6 time units. And then P5 will go out to I/O for 22 time units, and will be back in the ready queue at time 99. Next we have P6. P6 gets the CPU for 5 time units and will be done at time 82. We'll go out to I/O for 33 time units, and we'll come back into the ready queue at time 115. Next we have P7. P7 will get the CPU for 12 time units until time 94, and we'll go out to I/O for 38 time units, and we'll be back in the ready queue at time 132. Next we have P8. P8 gets the CPU for 5 time units, so it will be done at time 99, and we'll go out to I/O for 14 time units, and we'll be back at time 113. And then we have P9, and P9 gets the CPU for 13 time units until time 112. We'll go out to I/O for 47 time units, and we'll be back at time 159. So at this point, all processes have done their first CPU burst, which means you can now at this time calculate the response time. Response time can be calculated because it is the first measure from the time of arrival until the first time that the process gets on the CPU. And as of time 112, all processes have now gotten their first run on the CPU, so response time can be calculated. So now we might not continue to go in the same order because we need to go by order of when the process arrived in the ready queue. So let's take a look at the order that the processes are in the ready queue, and we can see that P1 got there at time 55, and no other processes got there before P1, so P1 will be the next one to go. P1 has a CPU burst of 20 time units, so it will go until time 132, and then we'll go back out to I/O for 42 time units, and we'll come back into the ready queue at time 174. Next, the current time is 132. The next one to arrive in the ready queue was P2, so P2 is going to go next. P2 has a CPU burst of 18 time units, so P2 will go until time 150. and we'll go out to I/O for 34 time units and come back into the ready queue at time 184. So now the current time is 150. The next one to go will be P3. P3 has a CPU burst of 14 time units, so P3 will be on the CPU until time 164, and then we'll go out to I/O for 19 time units, so we'll come back at time 183. Now the current time is 164. The next one to go is not going to be P4 because P4 didn't get in the ready queue until 106, but P5 got in the ready queue at time 99, so P5 is going to go next. P5 will go until time 169. We'll go out to I/O for 21 time units, and we'll come back into the ready queue at time 190. Now the current time is 169, and the next one to go is going to be P4 because P4 got there at time 106, P8 got there at 113, P6 got there at 115. So the next one is going to be P4. P4 has a CPU burst of 14 time units, so P4 will go until time 183, and we'll go out to I/O for 41 time units, and we'll get back into the ready queue at time 224. Now the current time is 183, and the next one to go is going to be P8. P8 has a CPU burst of 4 time units, so P8 will go until time 187. At time 187, P8 will go out to I/O for 33 time units, and P8 will get back into the ready queue at time 220. Now the current time is 187. The next one to go is going to be P6. P6 has a CPU burst of 5 time units, so P6 will go until time 192. At time 192, P6 goes out to I/O for 31 time units, and so P6 will come back into the ready queue at time 223. Now the current time is 192. The next one to go is P7. P7 has a CPU burst of 7 time units. P7 will be on the CPU until time 199. We'll go out to I/O for 40 time units, and we'll be back in the ready queue at time 240. So the current time is 199. If we look, we can see that P1 got there at 174, P2 got there at 184, P3 at 183, P5 at 190, and P9 at 159. So those are the ones that are currently in the ready queue. Still in I/O, we would have any of those that don't get to the ready queue before time 199. So the next one to go, because it got there first, was P9. P9 has a CPU burst of 21 time units, so P9 will be on the CPU until time 220. At time 220, P9 will go out to I/O for 31 time units and will be in I/O until time 251, at which time it will go back to the ready queue. Now the current time is 220. The next one to go will be P1. P1 has a CPU burst of 21 time units, so we'll go onto the CPU until time 241. We'll go out to I/O for 41 time units, and we'll come back into the ready queue at time 282. So the current time now is 241. The next one to go is not going to be P2 because P3 got there at 183 and P2 got there at 184. So P3 will go next. P3 has a CPU burst of 11 time units. So P3 will be on the CPU until time 252. And then we'll go out to I/O for 18 time units, and we'll be in I/O until time 304. 270. We'll be in I/O until time 270. Now the current time is 252. The next one to go is going to be P2. P2 has a CPU burst of 21 time units, So P2 will be on the CPU until time 273. At time 273, P2 will go out to I/O for 31 time units, and we'll come back at time 3:04. The current time is 273. The next one to go will be P5. P5 has a CPU burst of 15 time units, so we'll be on the CPU until time 288. Then P5 will go out to I/O for 31 time units, and P5 will get back into the ready queue at time 319. The current time is 288. The next one to go is P8. P8 has a CPU burst of 6 time units. We'll be on the CPU until time 294. Then we'll go out to I/O for 31 time units, and we'll get back into the ready queue at time 325. The current time is 294. The next one to go is P6. P6 has a CPU burst of 6 time units, so we'll be on the CPU until time 300. We'll go out to I/O for 32 time units, and we'll come back at time 332. The current time is 300. The next one to go is P4. P4 will be on the CPU until time 316. So you need to continue to do this for all processes until all processes have completed. And you only need to go up this far for your logic part, but I encourage you to continue going to make sure that you understand the logic very well so that you can implement it in whichever language you would like to.